Now, if you do a quick Google search for unit circle, you will probably see this gigantic circle with all sorts of really cool things on it, and a lot of important looking angles as well as ordered pairs that are on the unit circle. What I'm going to let you know is that the unit circle consists of a total of 17 angles on that unit circle, and with those 17 angles, you will need to know the degree measure as well as the radian measure. Now, associated with those 17 angles, two of them are actually going to be coterminal. The 0 degree and 360 degree, or 0 radian and 2 pi radian, will be the same. So there will also be 16 ordered pairs that you will need to know. Ordered, not ordered panes, ordered pairs. And each of those ordered pairs is going to be considered the cosine of the angle and the sine of the angle. Now, all of the angles that we're going to be dealing with will be reference angles of either 30 degrees, 60 degrees, or 45 degrees. So with that in mind, just wanted to give everybody a quick recall of what those two familiar looking triangles look like. 3 and 1 and 2. Now, the way that I like to describe this to my students is to remind them in a past life what I used to be. I used to be a pizza guy. Don't get me wrong, I still enjoy eating pizza, but back in the day, I enjoyed cooking up and slicing pizzas. So with that in mind, we are going to talk about 4 different ways to slice a pizza. And the way that we slice up these circles is going to give us all 17 of these significant angles. So for my first method, wow, that was, I am not getting better at this. The first way we're going to slice up the unit circle is with, to slice it up like we're going to have 4 slices of pizza. So the way that we do so is left to right, top to bottom. That is not very evenly sliced, but use your imagination. So the 4 angles in question will be in this direction, this direction, this direction, and this direction. Now first off, for degree measures, we just took 360 degrees, we sliced it up into 4 equal slices, which means that each of those is going to be a total of 90 degrees. Hopefully this looks familiar from our discussions on quadrantal angles. So 0 degrees, 90 degrees, 180 degrees, 270 degrees, and all the way back up to 360 degrees. All that I did is I just let the degree measure go up 90 degrees at a time, all the way around the circle. Now if we do this in terms of radians, we just took 1 full rotation, which is 2 pi radians, sliced it into 4 equal parts, and then we'll reduce that as much as possible. So the radian measures for these angles will be 0 radians, pi over 2 radians, 2 pi over 2 radians, 3 pi over 2 radians, and 4 pi over 2 radians. You'll notice that if I could reduce that fraction, I did so. Now, keeping in mind that this is the unit circle, all of these points are exactly 1 unit away from the center. So to the right, this would be an x-coordinate of 1 and a y-coordinate of 0. In the upward direction, this would be 0, 1. To the left would be negative 1, 0. And in the downward direction, this would be 0, negative 1. Now what we can do with all of this information is determine the sine, cosine, tangent, cotangent, secant, or cosecant of any quadrantal angle. For example, if I wanted to know what is the cosine of 90 degrees, then according to what we said just a moment ago, the x-coordinate will be the cosine. So we go to the 90 degree angle, and we say, what is the x-coordinate associated with 90 degrees? Well, that would be 0. So the cosine of 90 degrees will be 0. We could also consider something like the sine of 3 pi over 2. Sine is supposed to be the y-coordinate, so we head over to where 3 pi over 2 is, and we look at the corresponding y-coordinate. That would be equal to negative 1. We could also do something like the secant of pi radians. For the secant of pi radians, we go over to where we see pi as an angle. The secant is supposed to be the reciprocal of the cosine. The cosine is -1, so we could call this the reciprocal of the cosine of pi. That'd be the reciprocal of -1. This, of course, would be -1 as well. And finally, we could do something like the tangent of 90 degrees. By our fundamental identities, this would be the sine of 90 degrees divided by the cosine of 90 degrees. We did comment just a moment ago, though, that the cosine of 90 degrees is 0. That would put a 0 in the denominator. So we can't really have 0 in the denominator, so we simply say that this one is undefined. So this, not allowed, we simply say that it is undefined. So, next way that we can slice up a pizza, I mean a unit circle, is once again, we'll make this one a little bit bigger so that we can see all of the necessary details for it. For the next one, we are going to give this pizza pie 8 slices. And the way that we're going to give it 8 slices is start the same as we did before, one top to bottom, one side to side, and then cut each of these in half. This is going to give us a total of 8 angles and 8 ordered pairs associated with those. Now we just took 360 degrees and we sliced it up into 8 equal parts, which means that each of these angles that we created is 45 degrees. So starting at the positive x-axis of 0 degrees, we're going to count up by 45 degrees at a time. This is 45 degrees, plus 45 degrees will be 90 degrees, plus another 45 will be 135, plus another 45 will be 180, followed by 225, 270, 315, all the way to 360 degrees. You'll notice that we repeated all of the quadrantal angles in here. That is not only expected, but it is encouraged. So we could also do 2 pi in radians divided by 8, letting us know that we're going up by pi over 4 at a time. So starting at 0 radians, we're going to go up by pi over 4. That would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. Once again, as I was listing all of those off, if I could reduce it, I tried to do so. Now with that in mind, we already know several of these ordered pairs. We already know this one here, this one here, this one here, and this one here. The 4 new ones are the ones that are of interest to me. Now, for the 45 degree angle, something that I wanted to remind everybody of is the 45, 45, 90 right triangle. Now, we're supposed to do this in such a way where the hypotenuse is equal to 1, which means I need to scale everything down by a factor of the square root of 2. If I take 1 and divide it by the square root of 2, I will get the same as root 2 over 2. You'll also notice that the 45 degree angle is the same as the line y equals x, so I would expect the x coordinate and the y coordinate to be the same. Now, to take this and put it into other quadrants, it's simply a matter of saying, have I moved left or right, and have I moved up or down from the origin. For example, in quadrant 2, I would expect the x coordinate to be negative, and the y coordinate to be positive. And again, the coordinates will stay the same in magnitude because these are all reference angles relative to each other. Down in quadrant 3, this would be negative root 2 over 2 and negative root 2 over 2. And finally in quadrant 4, this would be positive root 2 over 2 and negative root 2 over 2. Once you have this circle constructed, you can find any of your 6 trigonometric ratios of any of these angles. For example, the cosine of 3 pi over 4. Cosine of 3 pi over 4, we turn to where we see the angle 3 pi over 4. Cosine is looking for the x-coordinate, so the cosine of 3 pi over 4 would be negative root 2 over 2. We could also take a look at the tangent of 225 degrees. Tangent of 225 degrees is going to be equal to, using fundamental identities, the sine of 225 degrees divided by the cosine of 225 degrees. That would give us negative root 2 over 2. Negative root 2 over 2 divided by negative root 2 over 2. Thankfully, those two numbers are equal to each other and we are dividing, so this thing is going to be equal to 1. And finally, we could do something like the sine. No, let's do the cosecant. That sounds even more fun. Of 315 degrees. This is supposed to be the reciprocal of the sine of 315 degrees. The reciprocal of the sine, we would be taking at 315 degree angle. The sine would be the y-coordinate. So we would be looking at negative 2 over the square root of 2. I'm going to rationalize this denominator to explain why this is equal to what it is. The root 2 times root 2 in the denominator will be 2. We'll still have a negative, and this will be 2 square roots of 2 on the top. You can then reduce the 2's so that you are left with simply negative square root of 2. Anytime you're dealing with these pi over 4s or 45 degree angles, you are going to see a lot of square roots of 2. Next up, one more way that we can take a pizza pie and slice it up is we could use 12 slices. To make a pizza pie with 12 slices, we do one top to bottom, one side to side. You are looking to do 2 additional cuts through here so that these cuts are all approximately the same size. You know what, that's not bad, but we still wind up with this little thing in the middle that if you're real careful you can take your finger and kind of like scoop out the extra cheese and, oh man, I'm making myself hungry. That was a mistake. So, take 360 degrees, split it into 12 equal slices. We would have a total of 30 degrees per slice. 0 degrees, and we'll go up 30 at a time. 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270 degrees. This is Sparta! 330 degrees, and 360 degrees. Now, in terms of radians, I just took 2 pi, split it into 12 equal parts, which means each of those 1 parts is going to be 1 pi over 6. So I'm going to start counting up by pi over 6 at a time. If I can reduce it, I will do so. So 0 radians, 1 pi over 6 radians, 2 pi over 6 radians, 3 pi over 6 radians, 4 pi over 6 radians, 5 pi over 6 radians, and 6 pi over 6 radians. 7 pi over 6 radians, 8 pi over 6 radians, 9 pi over 6 radians, 10 pi over 6 radians, 11 pi over 6 radians, and 12 pi over 6 radians. Should start to look a lot like a clock if you're doing it right. Now, referencing back a couple of sheets ago, I also mentioned that we are going to see several examples of the 30, 60, 90 right triangle. However, in all of these cases, I want to make sure that the hypotenuse is only 1. So I'm going to divide all of these by 2. So for the 30 degree angle, my x-coordinate is going to be root 3 over 2. My y-coordinate is going to be 1/2. I'm I'm going to take that and transfer it to the other three quadrants, making sure that the pluses and minuses are appropriate. So heading over into quadrant 2 would be at 150 degrees. This would be negative root 3 over 2 and positive 1/2. Heading down into quadrant number 3, this would be the next one. This is negative root 3 over 2 and negative 1/2. Following that horizontally into this quadrant, we would have positive root 3 over 2 and negative 1/2. Then for the 60-degree angle, this is going to swap the x-coordinate and the y-coordinate. This would be 1/2 and root 3 over 2. Follow that into quadrant 2, and we would be at negative 1/2, positive root 3 over 2. Following this down into quadrant 3, at 240 degrees, this would be negative 1/2 and negative root 3 over 2. Heading into quadrant 4, this would be positive 1/2 and negative root 3 over 2. Using all of these, you could figure out what is the sine, cosine, tangent, cotangent, secant, or cosecant of any of these angles. We'll start with my personal favorite. Let's do the sine of 300 degrees. For the sine of 300 degrees, we go over to where we see the 300-degree angle. Sine is going to be the y-coordinate. For the y-coordinate, that'll be root 3 over 2. Whereas if we did something like the cosine of 4 pi over 3, we go to the angle 4 pi over 3. Cosine would be the x-coordinate. That'll be negative 1/2. Whereas if we wanted something like the tangent of 150 degrees, we would have to find the 150-degree angle. 150 degrees is right here. Here are your two coordinates. This is going to be the sine of 150 degrees divided by the cosine of 150 degrees. Sine is the y-coordinate. That'll be 1/2. Cosine is the x-coordinate. That'll be negative root 3 over 2. The over 2's will cancel out and you'll be left with negative 1 over the square root of 3. Or if you feel like rationalizing the denominator, you could also call that negative root 3 over 3.